Hello children. Today we are going to start with the first lesson in geography, that is local time and standard time. In olden days, time was measured with the help of the natural events of sunrise and sunset and the instruments like Gatika Patra, that is water clock, sand timer, etc. Well, in present time we have instruments like watches, calendars, etc. Right? So, on the basis of these observations and experience, they divided the day into the following part: daytime from sunrise to sunset, nighttime from sunset to next sunrise, whole day, the duration from sunrise to the next is called a day. Rotation of the earth. The earth takes 24 hours, that is one day, to complete one rotation. During the rotation of the earth, the longitudes in the western part face the sun gradually, while those in the east experience darkness. That is, the longitude which faces the sun experiences sunrise, while on the other hand, the one in the darkness experiences sunset. As the direction of the rotation of the earth is from west to east, we experience the apparent movement of the sun from east to west. That is, while traveling in a bus, we often see trees, electric poles, buildings, etc. outside the window. They appear to be moving in the opposite direction. Actually, they are stationary. It is the bus that is moving forward. Similarly, because of the rotation of the earth, we feel that the sun is changing its position from east to west daily. Due to the rotation of the earth, we experience sunrise, noon, sunset, and midnight. Due to the rotation of the earth, the length and direction of the shadow change. In the early morning and evening, we experience long shadows falling in the falling in the west and east, respectively. We experience the shortest shadow in the noon. Local time. When the sun is directly overhead at a particular place, it is considered as noon at that place, and that time is considered as a local time of that place. During the rotation of the earth, when a particular longitude comes exactly in front of the sun, it is considered as noon time, that is 12 noon on that longitude. This noon time is considered as local time of that longitude. The noon time is the same at any given longitude across the earth, that is from North Pole to South Pole. In the regions lying in between the polar circles and the poles, the daytime could be more than 24 hours, depending upon the season. As the result, understanding the timing of sunrise, noon, sunset, and midnight at these places becomes important. At poles, the duration of the daytime lasts around 6 months. At the poles, sun rises on one equinox and sets on the next equinox. At the poles, the sun appears above the horizon and keeps moving around the horizon nearly for 6 months. That is, the sun will rise at the North Pole approximately on March 21st. Approximately from March 21st to 21st June, the sun will rise higher in the sky with each advancing day. It will reach the maximum height approximately on June 21st. Then again, from June 21st to September 21st, the sun will start sinking towards the horizon in the sky with each advancing day. The sun will set at the North Pole approximately on September 21st. To tell the time of sunrise or sunset at the poles, one has to consider the date. When the sun rises on a specific day, it moves around the horizon, and therefore, here the length of the shadow cannot be considered for telling the noon time. Okay, children, we stop here. I hope this much is very clear to all. In the next video, we are going to study about the longitudes and the local time. Before I wind up, now this is the activity which you need to do it in your notebook.
Worldwide time zones. In 1878, Canadian Sir Sanford Fleming proposed the system of worldwide time zones that we use today. He recommended that the world be divided into 24 time zones, each spaced 15 degrees of longitude apart. Please note, since the Earth rotates once every 24 hours and there are 360 degrees of longitude, each hour the Earth rotates 1/24th of a circle of 15 degrees of longitude. A time zone is a region of the globe that observes a uniform standard time for legal, commercial, and social purposes. Time zones tend to follow the boundaries of countries and their subdivisions instead of strictly following the longitudes, because it is convenient for areas in close commercial or other communication to keep the same time. The adoption of standard time, because of the correspondence between time and the longitudes, led to halving the globe into an eastern and western hemisphere. It has 10-degree line of longitude or prime meridian, as well as its opposite, the 180-degree line of longitude, also called the International Date Line, GMT, Greenwich Mean Time. Greenwich Mean Time is the time measured on the Earth's 0-degree line of longitude, or the prime meridian. This runs from the North Pole to the South Pole, passing through the old Royal Observatory in the London suburb of Greenwich. GMT was established in 1884 at the International Meridian Conference, when it was decided to place the prime meridian at Greenwich, England. The International Date Line. The International Date Line is an imaginary line on the Earth's surface, located at about 180 degrees east and west of the GMT prime meridian. The International Date Line runs down the middle of the Pacific Ocean. Please note, if you cross the date line moving east, you subtract a day, whereas if you are moving west, you add a day. For example, if today is Friday and we crossed the International Date Line from west to east, then it would be Thursday. Local mean time. Local mean time is a form of solar time that corrects the variations of time, forming a uniform time scale at a specific longitude. This measurement of time was used for everyday use during the 19th century, before time zones were introduced. It still has some use in astronomy and navigation. Standard time. Standard time is the synchronization of clocks within a geographical area or region to a single time standard. Rather than using solar time or a locally chosen meridian to establish a local mean time standard. Generally, standard time agrees with the local mean time at some meridian that passes through the region, often near the center of the region. Let us look at the map of the world with all the different time zones showing us prime meridian and the international date line. Thank you, students. Our next class, we shall learn more about our very own Indian Standard Time. Students, today we are going to learn about the Indian Standard Time. Indian Standard Time is the time zone observed throughout India with a time offset of 5 degrees 30 minutes. As you can see in the map, the difference between the GMT and the meridian passing through India is 5 degrees 30 minutes. The Indian Standard Time is calculated on the basis of the 82 degrees 30 minutes east longitude in the city of Mirzapur, Uttar Pradesh. The longitude on which the Indian Standard Time is based passes through Uttar Pradesh, Madhya Pradesh, Chhattisgarh, Orissa and Andhra Pradesh. After independence in 1947, the Indian government established the Indian Standard Time as the official time for the whole country. Although Kolkata and Mumbai retained their own local time, known as Calcutta Time and Bombay Time, until 1948 and 1955 respectively. The Central Observatory was moved from Chennai to a location at Shankargarh Fort in Prayagraj district, so that it would be as close to the 5 degrees 30 minutes longitude as possible. Now let us study the time difference in India. The time difference between Arunachal Pradesh and Gujarat if the sunrise at 4 a.m. in Arunachal Pradesh, the sunrise in Gujarat will occur at 6 a.m. Students, today we study the sums given in order to get a better grasp of the concepts. In example 1, Mashhad, a town in Iran, is located on the 60 degrees east longitude. When it is 12 noon at Greenwich, calculate the local time of Mashhad town. Statement. As we move towards the east of the prime meridian, the local time increases by 4 minutes for every longitude. The difference between the longitudes of Greenwich and Mashhad is 60 degrees. The difference in the local time is 60 into 4, which is 240 minutes. 240 divided by 60 minutes is 4 hours. So the answer is the time at Mashhad would be 4 in the evening. It was from 12 noon to 4 in the evening. Let us move on to the second example. by 60 minutes is 4 hours. So the answer is, as Manaus is located to the west of Greenwich, the local time of Manaus, not Greenwich, is 60 degrees west of Greenwich time by 4 hours. And therefore, when it is noon at Greenwich, it would be 8 a.m. at Manaus. Students, I hope you all have understood. When you move to the west, the time increases, and when you move to the east, the time decreases. Thank you.